in an effort to help us review transformations, I'm going to look at the greatest integer function, okay? So there it is. Whoa, hello. Okay, general. So A, regardless of what the function is, it's either going to have a vertical stretch or compression if it is something other than 1. B, horizontal stretch or compression if it is something other than 1. And remember, there's a negative in front of those. That means that there's a reflection. H is your horizontal translation, as is K a vertical translation. Okay, so the reason that we're going to use the greatest integer function is because it is the easiest for us to see what all of these transformations do. Okay, be careful with, and you've seen this on some of your, or you will on your weekly reviews, with the notation. F. F just means some function. We're defining f of x to be the greatest integer. So that means that it's going to be the greatest integer of x minus 5. Whoa, there we go. So this is the generic one, and then this is where we actually input the function. I need to fix that. I don't like that. Sorry. So everything is going to shift 5 units to the right. That's the transformation that's happening. Okay, so instead of starting, I'm going to try to make this bigger for us, at 0, 0, we're going to shift over 1, 2, 3, 4, 5 units to the right, extend out 1 unit, open circle, up, over, open, up, over, open, and so forth, because the only transformation that we're seeing is a shift 5 units to the right. Okay, if we go to the next one, again, the generic, g of x is equal to f of x plus 7. But we know that we have defined f of x to be the greatest integer function. So that means it's the greatest integer function of x plus 7. That means we're going 7 units to the left. So instead of starting at 0, 0, I'm going to go 1, 2, 3, 4, 5, 6, 7. Close circle, extend out, open. We don't have any other transformations, so we'll still go up 1 unit to the next step. Sorry about those obnoxiously large open circles. And we'll extend out 1 unit because there aren't any other transformations that we see. Okay, horizontal translations. Now here we're going to get to see vertical. It says that the function of x is going to shift up 2 units. So since we know that the function of x is defined in the directions to be the greatest integer function, I'm going to put the greatest integer function of x plus 2. Okay, so 2 units up. Instead of starting at 0, 0, we now start at 0, 2, extend out, and so forth. And then there aren't any other transformations, so we still extend out 1 unit and go up 1 unit. Okay, for here, again, f of x is going down 4 units. So f of x is defined to be the greatest integer of x in the directions, and then we take that and move it 4 units down. Good, okay, so we go 1, 2, 3, 4 units down. There aren't any other transformations. So we'll extend out 1 unit, we'll go up 1 unit. And continue on from there. Now I do believe, nope, doesn't say about domain and range. Okay, I won't add that in there. Okay, so then second row, we've seen horizontal and vertical translations. Now we are going to see if there's an a value on the outside of the function. That means 2 times the greatest integer of x. That means we have a vertical stretch. Now here's where we really get to see the beauty of the greatest integer function in relation to transformations. Okay, we're not shifting right and left at all. I still go 0, 0, I extend out 1 unit. But if my a value is 2, that means I'm going to go up 2 units to the next step. And we're going to really get to see that if your a value is 2, that means that you're stretching your function vertically. Okay, now if it's a half, well, this one's going to be fun. So it's 1/2 times the greatest integer of x. That means it's a vertical compression. Okay, so we still start at 0, 0. We still extend out 1 unit. But I'm going to go up 1/2. And it's going to be really hard on this super teeny tiny graph to make it look the way that I want it to. But every step is now going up half a unit in relation to the one that we have seen from the parent function. Okay. If we look, oh yes, the blessed b value. So function of 2x. The function again is defined to be the greatest integer. And, oh, that's ugly. We're going to have it of 2x, which means it is a horizontal compression. Now, horizontally, that means it is our step length. So I'm going to have to, start at 0, 0, and extend out a half unit, and then jump up 1 unit, extend out a half, and so forth. Oh my Lanta. Sorry guys, it's really hard with a pen. Hopefully, okay, hopefully you can see it. And hopefully yours looks better than mine. Okay. Now here, since it's f of 1/3 x, greatest integer of 1/3 x, we're going to have a horizontal stretch. This is going to be much easier for us to draw. So then I start at 0, 0, and I'm going to extend out 3 units. Yes. And up 1. And extend out 3 units and up 1. All because of that b value. So see, it's super nice. We're really able to see what these transformations do. Okay, so do me a favor and try, we'll do the reflections, and then I'll have you try them on your own. So we know if there's a negative on the outside, then it's the negative in front of the a value, which means that we have a vertical reflection. Okay, how do we think that's going to affect the steps? Well, we're going to flip them upside down. So I still start at 0, 0 and extend out, but now I'm going to go down because everything is reflected across the x-axis. And I'll do a couple up here also. Okay, so then if it's on the inside, that means it's affecting the x values, which means it's that horizontal reflection. If it's on the outside, it affects the y values. Let us not. So then we have 0, 0 still, but everything's now going to extend to the left. And we go down. Okay, so horizontal reflection for the greatest integer function, that was the funky one, because not only do we extend to the left, but then we also go down. All right, here we go. There's this one that I want you to pause the video, please. I'm going to pause it right now, and I'm going to do it, and then check it when you're done. Okay, how'd we do? So since there's a 2 on the outside, that means we are stretching the steps by 2 units, and everything shifts up 1. So instead of starting at 0, 0, we now start at 0, 1. How'd you do? Let me know. Okay, so then, oh gosh, here we go. I'm going to pause one more time. We do have a b value, so be careful, guys. Pause your video, please, and try it. How'd we do? Okay, so looking at it, we have that vertical stretch with the 3. There is a horizontal reflection, which means you're going to extend the step to the left and go down. And there's a horizontal stretch, which means the step extends to the left for 2 units. And there's a vertical translation, so we go down 2 units. Hopefully this was a helpful reminder.